This is Coulomb's law. Wait a minute, this is just Newton's law of gravitation in disguise. This tells us that electric charges attract each other in a similar way masses do. Opposites want to cuddle, while like charges literally couldn't think of a more disgusting thing than to be with one another. These four equations explain pretty much all of electromagnetism, but don't be scared just because they look scary. I mean, yeah, they do, but it's simpler than it seems at first. The first one states that if there is an electric charge, there will be an electric field, or this big E, emerging from it. Add another and you have an electrostatic field. These lines tell us in which direction a charged particle would feel a force at any given point. The second one tells us the same for magnetic fields, and even though electric charges are cool and can be alone, magnetic poles are not. They're very lonely, and there will always be a north pole together with a south pole, and a single pole can never be alone. Okay, now here's where things get kinda freaky. You know how electric charges only act on other charges and magnets only affect other magnets? Well, that's only true if they're not moving. The third and fourth Maxwell equations tell us that a moving magnet creates an electric field and a moving charge or electric field creates a magnetic field. One consequence of this is that current can seemingly come out of nowhere by moving a magnet next to a conductor. The moving magnet creates an electric field which makes the electrons inside the conductor go crazy. That is called induction. In other words, electric and magnetic fields are so tightly linked that they are two parts of the same bigger thing. Let's say we have a charge. Since it doesn't move, it has a static electric field. If we accelerate the charge, there will be a magnetic field around it. That magnetic field interacts with the electric field, which again changes the magnetic field, and this is a sort of chain reaction that makes the electromagnetic field radiate outwards into space as an electromagnetic wave. Depending on the frequency, the human eye can actually see this. It's called light, but most of the spectrum is invisible to the human eye and is used for things such as Bluetooth, wireless charging, and confusing human apes into thinking magic is real.